Hi, everyone. Welcome to Chapter 12. In this section, we are going to be working with statistics. In this particular section, we are going to be talking about visual displays of data. So we're going to be talking about different types of data. So section 1, 12.1, visual displays of data. What we're going to be doing in this section is we are going to be constructing and interpreting data displays. We're going to construct and interpret frequency and grounded frequency distributions. We're going to talk about stem and leaf displays, and then we're going to look at bar graphs, circle graphs, and line graphs. So many times in statistics, we display data in different types of graphs and displays. So we need to understand how to display them and how to construct them. Let's talk about the basic concepts of a statistic. So a population represents all items of interest. So one thing is the definition of a population versus a sample. So a population is all versus a sample is only a portion. It's only a portion. It's ordinary, not all the items in the population. What are the main areas of statistics study? So there's two types most of the time. It's descriptive statistics. What it does, it collects, it organizes, summarizes, and presents data. This is the basic types of describing data, whereas an inferential statistic consists of drawing conclusions based on populations that are taken from samples of these populations. So the descriptive is just the collecting, the organizing, the summarizing. The inferential is where you start doing formal conclusions and hypotheses testing based on a population. So we'll begin with looking at basic concepts. Once the information has been collected but not organized, it's called raw data. So you've only collected the data. You haven't processed the data. You haven't found anything about the data. Um, you, you have a raw data. That raw data is most of the time a numerical value, but it could also be qualitative or non-numerical. So it depends on what type of study you're doing. So most of the time, it's going to be a number, a numerical value that you're collecting. For example, if I want to know the height of the students in the class, it's going to be a numerical data. Where if I'm looking for what's your favorite food, that's going to be a qualitative, a non-numerical data. So it depends again, what am I collecting from you? So let's begin by looking at the types of data. Let's say we're looking for the number of siblings in 10 different families. So you can have three siblings, one sibling, two, one, five. These are all quantitative. They're represented by a numerical value. They represent something, a value actually. You have qualitative data that makes five different automobiles. So different brands like Toyota, Ford, Nissan, Chevrolet, and Honda. So all of these are qualitative, right? They're not a numerical value. But you can have quantitative data that could be sorted in a mathematical order. So 1, 1, 2, 2, 3, 3, 3, 4, 5, and 8. So the way that you also categorize your data is important when you're doing statistic. And if you want to do it efficiently, there is a sequential way that you want to write your numbers so it's easier for you to track. Of course, there's also different types of data. Like, what if I'm looking for a rank? That's unnecessarily quantitative. So if I want to know, let's say like Princeton, Harvard, and Yale, there's three different ones. And if I want the ranking, so one, two, three represents rank, but they're not necessarily quantitative, right? Because I'm asking for the universities in rank. Let's talk about, so once you have data, you can sort the data. So we're looking for sorting the data. If I want to sort the data, I use a type of distribution. So in this case, I can look for a frequency distribution. So what is that? When a data set includes many repeated items, it could be organized in a frequency distribution, which lists the distinct values of X, along with the frequency. It is also helpful to show the relative frequency. So one thing is how many times it shows the frequency of the amount, and the other is the relative frequency, which is represented by a percentage of each item. So what we're going to be doing is that we're going to be given data and then we're going to be creating that so-called frequency distribution. Let's look at this question. We want to construct a frequency distribution, a frequency and a relative frequency distribution. The 10 students in math classes were polled to construct a number of siblings using their individual families. We're going to be constructing a frequency distributions and a relative frequency distributions for the responses below. So the first thing you want to do is you notice that you have repeated values. You have repeated values. So you have a 1 and then, so only 1. And then the 2 will have 1, 2, 3 twos. So there's 3 out of, here we have 1 out of 10 because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The sum is 10. So 10 total values. One, the value of 1 shows up 1 time. The value of 2 shows up 3 out of 10 times. The value 3 shows up 1, 2, 3, 4 times, 4 out of 10 times. And then 4 shows up 2 times. 4 shows up twice, or 2 out of 10. Now, the way that we start is look at, well, the number of x. There's the number of x, how many times it shows the frequency, how many times does it show, and the relative frequency is how many times from the total. 1 out of 10, that's 10%. 3 out of 10 times, that's 30% of the time. 4 out of 10, 40% of the time, and 2 out of 10 is 20%. So the highest value, or the value that shows up the most, 40% of the time, you'll get a 3. So 3 siblings is the most popular, and this is the way that we construct a relative frequency distribution. So first we identify the value of x. So there's 1 sibling, 2 siblings, 3 siblings, or 4. Then we look at the frequency or the repeated. How many times is it shown? Repeated how many times? 1 time, 3 times, 4 times, 2 times. And then the frequency is the amount of repetition over the total. And the total is the sum of your values. So n is the total. So there was 10 values. And it looks like a table where you have a column for your x's, a column from your frequencies, and a column from your relative frequency or a percent. So 10%, 30%, 40, and 20. So most of that time, that column, that row, will be found to be a fraction or a percent. Now, what about a histogram? So actually, the histogram is a representation or a display, of your relative frequency, relative slash a frequency table. So basically, it's a display. So the data from the previous example can be interpreted as an aid of a histogram, a series of rectangles whose length represents the frequency. So that y values, like the y values are represented by the frequency, and the x values are the siblings. So these x values are the amount of siblings. So 1 sibling only was 1, 2 siblings was 3, 3 sibling was 4, 4 siblings was 2. So then most of your data, we said this was 40% of the data. And then this was 10%. This was 30%. And then this was 20%. And all of the percent, so 10 plus 30 plus 40 plus 20 give you your 100%, which is your data. Now we can also create a frequency polygon. That is another display that we can create from a frequency distribution. The information can also be conveyed by a frequency polygon. Since the plot is a single point, so we have 1, 1, we have 2, 3, 3, 4, and then 4, 2, where the x value again is the number of siblings. And then the y is the frequency. So it's like an XY plane, and then here was 1, 1. But then the thing is, you put the plots, and then once you plot them, you create a shape or you create a polygon. So it's going to be line segments that will create a type of shape or a type of polygon here. So first you plot the points, which is your frequency distributions right here that you had. So 1, comma 1, 2, comma 3, 3, comma 4, 4, comma 2. You place them as points, as coordinates, and then you create. So you plot the coordinates, which is the x value or the number of siblings, and then the frequency. And then you create line segments and you form a polygon. We can also do a line graph. Look at the difference between the line graph and the frequency polygon. The frequency polygon is an instinct of a more general line graph. So see how here we don't actually, the difference is we don't follow the trace. So we only take care of the points. So again, the points 1, 1. Here we get 2, 3, 3, 4, and then 4, 2. But then we don't end it, right? So we miss, we don't finish, we don't create a polygon. That's the difference between the line graph polygon. We don't create a polygon. We just create the line segments. We don't finish it off, right? So that's what missed between the line graph and a frequency polygon. So they're very common, except look over here. They actually do finish it right here. So they finish the dots. They actually create a polygon, where here we don't. Because we're not interested in looking at a shape. We are interested in just looking at a line. Now, when we're looking for grouped frequency distributions, the definition is that data sets contain large number of items that are often groups of or classes. So they might not just be 1, 2, 3, 4, 4, 4. So it might be a group or a class. So all data items are assigned to their appropriate classes and then grouped. We're going to use a grouped frequency distribution. And that's because we probably are going to get data where it's going to range between 1 and 2, or 1 and 10, and 10 and 20, 20, 30, 30, 40, and then we count. So we're going to create a setup of different data, a raw data that includes many different data values, where we're going to have to create them in groups or assign a different class. That's called a grouped frequency distribution. So there's the basic frequency distribution where it's just a set of data values, or there's the group frequency distributions, and that's because we have larger number of items. So what we're going to be doing for those, there's particular guidelines that we need to follow when we're doing a group frequency distribution. So first, we need to make sure that the item fits into one of the categories or one of the classes. Only one. So you can't be in one class and then at the other. It only must fit one. We try to make all classes the same width. So we need to make sure that all of the width classes, so if I'm doing, so for example, if I'm looking at a class of width 5, it's going to be 1 through 6, and then, or 1 through 5, and then 6 to 10. So I'm looking at the width to be 5. The width has to be consistent. So we want to make sure that no classes overlap. So I can't have 1, 5, and then 5, 10, right? Because then you repeat the 5. So it should only be at a single class. We can use anywhere from 5 to 12 classes. If it's less than 5, it might be too few, or if it's more than 12, it might be too many. So we want to make sure we stay within some boundary points, some boundary number of classes. So what we're going to do is, this is an example of, we want to create a tabulate group frequency distribution and a relative frequency distribution, and construct a histogram from scratch. So 20 students, so there's the value of n, and it's 20. It's saying selected randomly were asked to estimate the number of hours they had to spend studying in the past week in and out of class. The responses are recorded below. It's saying we want to tabulate a group frequency distribution and a relative frequency distribution and construct a histogram for the given data. So what we're going to do is that we want to first look at the data that we have. So we have 15, 58, 37. So we can do it in 10, 20, 30, 40, and 50, which seems accurate. We want to create, and we want to be able to split our data in different brackets or different classes. So we have to look at the 20 and we have to look at the repetition. Do we have anything that repeats? So let's start by looking at, do we have anything that kind of repeats itself? So what we're going to do is we're going to be looking at splitting this into number of classes first. And we said, okay, we want to look at a list of tens, right? So if I look at my data, I have a 15 and I have a up to a 58. So that means I want to create a width of 10. So see how this is 10 to 19 and then 10, 20, 30, 40, and 50. So my class width is equal to 10. I'm splitting in brackets of 10. You're going to know because that's 10 to 19. Yes, I know. So first, you're going to look at how many fit. So how much data are in between in the classes. So the first one is between 10 and 19. Who is between 10 and 19? 1, and then that's about it. Only one. So only one lives in that class. Anywhere, so what about 20 to 29? So 20 to 29, I have 1, 2, 3, 4, 5, 5. So 5 live in the brackets 20 to 29. How many do I have from 30 to 39? So different color. 30 to 39, I have a 37, I have a 36, and then and a 36. So that's 1, 2, 3 data. So that's 3 data. How many data sets are between 40 and 49? So 40 to 49, a different color. So 1, 2, 3, 4, 5. So 5. That's between data 40 to 49. What about 50 to 59? So 50 to 59, it's how many do I have? I have 1, 2, 3, 4, and 5. Oh, and I'm missing one. So it's going to be 1, 2, 3, oh, 4, 5, 6. I miscounted. And that can happen as well. So then we notice that I have one frequency, 5, 3, 5, and 6. Then the relative is 1 out of 20, 5 out of 20, 3 out of 20, 5 out of 20, and 6 out of 20. And then we can calculate, well, what's 1 out of 20? If I plug in 1 out of 20, that's 0.05 or 5%. So 5 out of 20 is 1/5 or 25%, right? So 25% or 5 out of 20. I'm sorry, that should be 1/4, which is 0.25. And then again, this is 15% or 0.15. And then again, 5 out of 20 is 1/4 or 25% of the data. And then 6 out of 20. So then most likely it's going to be 50 to 59, the number of hours that people are studying, 50 to 59. And first, what we had to do, step one, is to categorize our data in a way where it could be simplified. And you're like, well, I don't know. What if my data is a little bit more than 20? Can I split it in 4? So you need to make sure that when you're looking at your data, you're paying attention to the class width. Okay, so what's going to be the length that I'm going to stick with? It's always nice to work with fives and tens. That would be your guide. So make sure you always kind of cut your brackets to a nice number um, where it's tens or fives, right? You don't want to go too short where it's like an even number, but you want to make sure that your data is spaced out. So now that we have the data, so these are our classes, and the height is our frequency. So the first one was only one. There's a frequency one time. This was 5 out of 20. This was 3 out of 20, three times. And then this was 5 out of 20. And then this one was 6 out of 20. So remember, look at the height is the frequency. The numerator is the frequency. So then we create this bar graph that will shadow everything that we've done. And again, the max data or the one that kind of dominates is the 6 out of 20 or the class that's 50 between 50 and 59. Now that's a histogram. We also want to create a frequency distribution. So in the table, we listed 10, 20, 30, 40, and 50. These are lower class limits. So see how we started with the, the lower class limits are 10, 20, 30, 40, and 50. Then we have upper, which is 19, 29, 39, 49, and 59. So we have something called lower class limits in our when we're looking at our classes, and then we have an upper class. The upper classes are going to be the highest values of each class. So 19, 29, 49, and 59. And the class width of the distribution is the difference between two successes. So for example, we had 10 to 19 and then 20 to 29 and then 30 to 39 and so on. So if we subtract 20 minus 10, we get 10 and then another 10 and then another 10. That tells us the class width. So the class width for this particular distribution was 10. Now that we've seen a frequency distribution as a frequency and as a class distribution, we can look at a different type of display, and that's called a stem and leaf display. When you have a stem and leaf, it looks something like this, where you have the values of tens here and the digits, the one digits here. So digits are 0, 1, 2, 3, so on up to 9. The tens would be, of course, 10, 11, 12, so on and so forth. So if I'm interested in writing 10, it'd be 1 and 0. 12 would be 1 and 2. Or 10, comma 2, comma 3, that would be 10, 12, and 13. If I have 21, 22, and 23, 21, 22, and 23, that's the way I would write it out. All the tens on one side and the digits on the other. So 10, 12, 13, 21, 22, 23. So what we're going to do is we're going to be creating here the display from the last example where we had 15, 20, 30, 40, and 45. So we have a 15, 1, 5. That's the only one. And then we had a 20, 27, and they must be in order. They must be in numerical order. That's very important when you're dealing with displays. Numerical order. So 15, 20, 27, 28. There's two 29s, so I have to write it the 9 two times. 36, 36, 37, 40, 42, 42, 43, 46, 51, 51, 55, 56, 57, 58, 58. So again, 51, 55, 56, 57, and 58 two times. And that would be our data. So when we're looking at a stem and leaf, again, the tens will be here and the digits on the other. Numerical order matters 100%. So first you take your data, you organize your data to make sure it's in order, and then you write it out. We are also going to look over bar graphs. Most of you are familiar with that type of graphs. So a bar graph is a frequency distribution of non-numerical. So they're non-numerical here. For example, if I'm looking at the classes that are food, represented food. So let's say pizza. How many of you like pizza? How many of you like Chinese food? How many of you have like sushi or so on, right? So let's say that three of you like pizza, five of you like Chinese, and then 20 like sushi. So then you have this sort of bar graph that are represented by a non-numerical data, right? So they don't represent some type of number, but they represent a category. So this bar graph shows the number of vowels in the sentence. So A, E, I, O, U. So then there's the frequency, two vowels, two A vowel sounds, seven on E sounds. I, there's four, O, four, and then U, only one. So this sentence. So sentence in this sorry, this graph shows below plays the number of vowels in the sentence. So once you say that, you start counting how many vowels. Then there's two vowels in the letter A. There were seven vowels in E, four in I, four in O, and one in U. And again, this is a category of vowels. Vowels is a non-numerical value. We can also have circle graphs, or also called a pie chart, which uses you circle, like the actual circle, to represent all the categories. So again, a circle graph or a pie chart is used. Um, it's used for categorical data or non-numerical. You could say you can have categorical or non-numerical, but you can also have like percentages. 20% of the pie or 30% of the pie. For example, a category representing 20% of a whole should correspond to a sector. So you have a uniform. So let's say it depends. You want to make sure they're in equal pieces. If this is a fourth, if this is a seventh, there should be seven pieces. Um, it depends on what I'm looking for, but the degrees should always match 360. So on this one, it's saying, okay, we want 20% of 360. So 360 times 0.2, it's 72 degrees. So we want to make sure that we want to divide it out properly where we are looking at the correct particular sector that they're asking for. Now, this is an example of a circle graph. This is a general estimate of Amy's monthly expenses are illustrated on the graph. She spends 10% on clothing, 25% of her expenses go on rent, 30% go on food, and the remaining other would be, for example, like gas right now, especially gas, phone bill, any other bills or any other expenses that you can think of. That would go into the other. But you can split, see how they are different percentages, but they all enclose a circle of 100%. We also discussed a line graph. If we are interested in demonstrating how quality changes, we want to use a line graph. So what the line graph does, it really categorizes like different types of changes. So we connect a series of segments that rise and fall with time. There's also a time series graph that goes with a line graph, um, which is exactly what we see here. So the example of a line graph. So see how we have a line graph that are represented by dots and they're just segments. So the line graph below shows the stock price of a company, PCWP, over a 6-month span. So these are your 6 months, that's X, and then the amount, the fluctuation of the price of those stocks, that they will obviously fluctuate with time. So what is a time frame reflected in from January to June? So notice that it's going to increase and there's going to peak at March and then it's going to be decreasing. The lowest would be at May and then it's going to rise again in June. So then just it's very easy to interpret when we have a line graph. You can kind of describe what's going to happen in the next 6-month span. And with that, we finish section 12.1. Thank you. Section 12.2 discusses central measures of central tendency. This is where we're going to see the mean, the median, and different types of things that you've kind of worked with already. So the objectives of this lesson is to find and interpret means. So for these types are very easy, very simple. There's also a lot of calculator operations that can be done. So you're going to be able to use your calculator. If you have large data, if you want to find the mean, you're going to be able to list that data and then hit one vars, and that will tell you what the mean is, the median, not the mode, because modes are very easy to detect, especially um, most of the time they're repeats, right? We're going to talk about inferences of central tendency measures from a stem and leaf display. And then we're going to discern symmetries in data. So what does that mean? We're going to be comparing central tendencies. So we're going to compare all these three. And what do they mean? Again, all of this chapter is about statistics in general. So let's talk about a definition. So for a given number of sets, so for a given set of numbers, it may be desirable to have a single number that serves as a kind of representative value around which all of the numbers is set to tend or cluster, kind of the middle. So we're going to be looking for measures of central tendency. Three such measures are discussed in this section: the mean, the median, and the mode. We'll start with the mean. The mean, or properly called the arithmetic mean of data, is found by adding, so there's a formula on how to find the mean, and that's going to be by adding all the numbers and then dividing it by the sum. The sample mean is denoted by x bar. So pay attention to those variables that are denoted. So x bar, it's called the sample mean, where mu is called the population mean. So x bar, sample mean, because in statistics it's always split it in two parts, the population and the sample. And then mu is going to be the population mean. So the formula of finding the mean, let's say you have x1, x2, different data. The way that you would find the mean of the data would be you're going to be adding all of the values divided by how many numbers were you given initially. So x bar, the sample mean, is the sum of x divided by x. Let's say that I have this formula. We have the sum of the 10 students in a math class were polled. We want to find the mean. So the one thing that we have to do is add all of the values and divide it by 10 because there was 10 total. So we're going to add 3 plus 2, 3 plus 2 plus 2 plus 1 plus 3 plus 6 plus 3 plus 3 plus 4 plus 2 all over 10. Let's punch that in our calculator. We're going to get 2.9. Another way to easily calculate that is if we go to calculate 84, let me go ahead and project that in my computer. So here's my screen. I'm going to clear it out. I'm going to go to edit. I'm going to go to stat, edit, and then I'm going to remove whatever I have. So I'm going to delete it, and then L2 delete, and then L3 delete. Make sure you only have one entry. So you're going to put in the values 3, 2, 2, 1, 3, 6, 3, and then another 3, and then 4, and then 2. I will need to make sure I have 10 entries. Once you've inputted all of your entries here, you're going to go to stat, calc, 1 vars test. Hit enter. Now it's going to give me this X bar. If I'm trying to zoom in here. X bar is 2.9, which is our mean. And then we have the sum of X, which is 29. We have a SX, which is called the standard deviation, which you don't know that yet. There's the value of N, how many data values N. And then we have this med, which is the median. The median is 3. So when you're doing these things, you can make sure that you're saving some time. Now, there's a difference between the mean and the weighted mean. The weighted mean of n numbers, let's say you have x1, x2, x to the n, it's actually weighted. An example of a weighted mean would be your grade point average, right? For example, the value A has a 4 points. The value B has 3 points. The value C has 2 points. The letter F has 0 points. So the way that we calculate a weighted mean, again, this is a sample weighted mean, is that we're going to take the product between X and F, the value of X times the frequency, or by the weight. We're going to add that and then add it by the frequency. How many times or how much value is the weight? So here's an example. So first, let me put that in here. So W bar is equal to the sum of X times F of F over the sum of F. So we're going to do an example. In a common system for finding a grade point average, A is 4 points, 3 is B, 2 for C, and 1 for D, and 0 for F, of course. We wish to find the grade point average by multiplying the number of units for a course and the number assigned for each grade. Then we're going to add these products. Finally, we're going to be dividing it by the sum of the total number of units. So how many units? That's the frequency. And we're going to be finding the weighted mean. So here's an example. We wish to find the grade point average or the weighted mean for the grades below. So this person got an A with 5 credits, B 3 credits, 4 points, and then 2 points. So we're going to need the sum of units. So how many times of units? So the sum of units would be 3 plus 5. That's 8 plus 2 plus 2. Here we have 12 units. So that's how many units that this person took. So 8 plus 4 is 12. Now we're going to take X times F. So we have 4 times 5. And then we're going to have to add that. So we're going to need the sum of the product. So plus 3 times 3 plus 4 times 2 plus 2 times 2. So then we're going to have 20 plus 9 plus 8 plus 4. So we have 29 and 12. That gives us 41. But again, the formula is X times F of X, the sum divided by the sum of F. So here we have 41 over 12. So when we calculate 41 by 12, we're going to get roughly between 3.416. But this is a grade point average, so this is a typically 3.4. So it'd be round off to 3.4 or 3.42. So it depends how many decimals they ask for. In this case, if it was 1 decimal, it'd be 3.4. But if this was 2 decimals, it's 3.416, which is 3.412. So that would be our solution. Now, another measure of central tendency, which is not so sensitive to your extreme values, is actually the median. So why it's saying not sensitive? Because the mean is sensitive. It's sensitive to outliers. So if you have data that's kind of off, it's highly sensitive, where the median is not so sensitive. Because since it's only the middle number, it's really not affected by the greatest number or the smallest number. So we look at the median. The median is the measure that divides it into 2 parts. So it's actually half. So to find the median, we want to make sure that's always in order from least to greatest. We always want to make sure that it's designed in a form that it's always the least to greatest. The step 2 is if you have the number of items is odd, then the median is actually the middle number. But if it's the number of items is even, then you're actually going to have to find the mean of the 2 middle numbers. So it actually depends. So if the total number of values that they give you is odd, it's actually going to be the middle. Whereas if it's an even number, then you're going to have to take the two middle numbers, add, and divide it by 2. So let's look at this example. Well, first, see how these are not, we already know what the answer is. We saw that from our first example when we were looking at mean. We didn't order the data, but that's what we want to do. So step 1, order data. So make sure that you're ordering the data in a way that it's in from least to greatest. So I have 1, 1, 2, 2, 2, 1, 2, 3. So, and then I have 1, 2, 3 threes. So 1, 2, 3, 1, 2, 3, and then 1, 4, 1, 4, and then 1, 6. So if I'm looking for the median, you cross, 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 cross. See how you have two middle numbers? Because n is 10. So this is even. That means you're going to take the two middle, divide, and find the mean of these two numbers. So it's 2 plus 3 over 2, 5 over 2. And that would be 2.5. So the difference between this data was we had to reorder it, and they actually added the value. So we got 2.5 as our median because n was 10. Now, there's also a position to finding the median. So let's say if I want to find the actual position, it's always going to be n plus 1 over 2. That will tell us exact the position, but not the actual value. Note that. So let's say that we had n plus 1 over 2. For the previous, n was 10. So it'd be 11 over 2. That's roughly 5.5, right? So that means I'm looking at the fifth position. 1, 2, 3, 4, 5, right in the middle, 5.5. So that means you have to add and divide by 2. So that would tell me the position, not the actual value. So that's a hint on the position on how to find the mean, the median in this case. So now what happens if I want to find the median from a frequency distribution? Well, it's saying there's the value and there's the frequency. So the first thing you want to do, so you want to kind of sort the data. You have 4 ones, 1, 1, 2, 3, 4s, and then you have 2, 2, 2, and then you have 3, 3, and then you have 1, 2, 3, 4, 5, 6 fours, and then 5 eights. 1, 2, 3, 4, 5, 6, 7, 8. So now how many values we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. N is 23. So let's plug it in. So we get 23 plus 1 equal 24 divided by 2 is 12. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Boom. So that 12th position was a 4. So you want to make sure that you list your items in order and then follow the position formula. Now the mode is very simple because the mode of a data is the one that occurs the most. But there's more, it could be more than one mode. You can have one mode, two modes, three modes. So you can have one single mode that dominates, that's the highest. So for example, on the last example, the 5 is the mode. The 5 dominates because it occurs 8 times. So 5 would be the unique mode. But what happens if in a distribution you have more than one mode? That means you're bimodal. So for example, you have 10 students in a math class. So see who dominates. 1, 2, 3, 4. So there's 3 4s, and then there's 1, 2, 3 2s. So who dominates? The 3. 3 number of siblings. So which one shows up the most? Which data value shows up the most? You can have 2 data sets that shows the same amount of times or no repeats. So if there's no repeats, that means you do not have a mode. Same here. The mode of 5 is the highest because it has the number that repeats the most. It has 8 times. The 5 occurs 8 times. Now, what we could see is that central tendencies from a Stefan Leaf display. So remember how we have let's say like the display. So 2, 3, 4, 2, 2, 2, 5, 5, 3, 3, 7, 7, 7, 7, 4, 4, 0, 0, 1, 1, 1, 1. Let's say that this was my data, and I want to be able to find the mode. Well, the mode shows up the most. So this would be 37, 1, 2, 3, 4 times, 40, 1, 2, 3, 4 times. So your mode would be 37 and 41, right? This is an example. 22 shows up 3 times, 25 2 times, 42 times. The most is 37 and 41. So that would be our mode. The median, we would say, okay, how many values do we have? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have n to be 20. We have the function n plus 1 over 2. That would be the position. So it's 21 over 2. That's 10.5. So we have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and then in the middle between 33 and 37, add and divided by 2. So we would have to do 33 plus 37. That's 70, 70 over 2. So that would be 35. So our median would be 35. And then our mean, well, we just add and divided by n. So here's the example. Below is the stem and leaf of some data. Find the median and the mode. The mode shows up the most of 42, 42, 42. That shows up 3 times. And then the median, again, you have to count. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So n is 21. You use the position formula. So it's going to be 21 plus 2 over, 21 plus 1 over 2. That position would be the 11th, divided by 2. That would be the 11th position. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the position would be 37. That would be our median. So very close. So looking at the symmetry and statistics, the most useful way to analyze a data, it actually depends if your distribution is symmetric versus not symmetric. So what does a symmetric mean? A symmetric distribution is, as if you want symmetry, you want to make sure that your data is kind of centralized. It has some symmetry. Which happens on your right happens on your left, right? It's like a shadow. You want to make sure that we have some frequency that will have symmetry versus where we don't have symmetry. They're all kind of the same, right? Let's say that your data is kind of uniform. So this would be symmetry, or symmetric, versus non-symmetric. So these are some symmetric ones, a uniform distribution, a binomial distribution, and a bimodal, right? Because you cut it in half, you kind of see the behavior. Non-symmetric was if you have any skewedness. So if you're skewed to the right and skewed to the left, let me give you some examples. This is skewed to the left, skewed to the right, skewed to the left, because look at how your data is. So the tail is to the left. This one is to the right, and this is a bimodal, so it's not skewed. So in summary is that the mean is the set of numbers that's found by adding and dividing it by the total numbers you have. The median is kind of the middle number. It helps you to rank values. If you have an odd number of values, it's the number in the middle. If it's an even, you're going to have to look for the median. And we also have the position formula to help you find the median. And of course, the mode is the value that occurs within the greatest number frequency for some sets, where you can have a bimodal or no modes at all. If you don't have any repetition, well, then you don't have a mode. So those are three are our measures of central tendency. Thank you so much. I'll see you guys in the next video. So far we've covered 12.1, 12.2. Thank you.